Hello everyone and welcome to the third presentation in the Nuage Networks SD-WAN for Retail series. In the previous demo, we have shown how easy it is to bring up a retail location in the existing retail business infrastructure using Nuage Networks SD-WAN solution. This video will focus on another challenge discussed in the first presentation. This is maintaining a consistent security policy across all locations. Heterogeneous environments having separate management and control planes are complicated to manage. One needs to have separate security policies in each environment, data center, public cloud, or WAN. This leads to configuration inconsistencies across the distributed locations, causes the lack of centralized view of the network elements and traffic flows, and also adds a lot of complexity as the network grows. The solution to this problem is having a network connectivity solution that spans the entire infrastructure, whether it's WAN, data center, or public cloud, and provides a single unified configuration policy. It provides highly available centralized management and control planes. Therefore, this allows to have consistent configuration across all distributed locations. In the demo, we have the following distributed locations. The data center containing business applications, 2 public cloud platforms, 3 remote branches, each containing 3 different zones: back office, consisting of PCs, IP phones, and printers, the user Wi-Fi zone, and the sales, containing wired and wireless points of sales equipments. All these remote locations are connected either via Internet or Internet and MPLS links. In the demo scenario, we have the following communications. The point of sales terminals from every branch need to communicate with the sales app in the data center. The user Wi-Fi needs only to be able to go to the Internet and certainly must be isolated from other subsystems. The IP phones in the back office of every branch need to talk to the VoIP system in the data center, and the PCs in the back office need to be able to communicate with the inventory service in the data center. However, there has been a security audit and there have been found violations of the security policy. In some branches, the user Wi-Fi zone was allowed full Internet access instead of only ports 80 and 443. And some branches were authorizing full back-office access to the inventory service, printers, PCs, and VoIP phones, instead of only PCs. Since the inventory platform has sensitive information, it is crucial to only allow access to authorized persons to it. Now, if this was a legacy network environment, this would mean that someone would manually have to connect to every firewall deployed in every branch and implement the security rules to fix the vulnerabilities. This is a very long and error-prone process. Instead, we will show how fast this can be fixed with Nuage Networks SD-WAN environment, where centralized security policy is used. Let's now move into the demo. Let us first take a look at the logical topology in the Nuage Networks Virtualized Services director. We have our branch backoffice domain containing 3 zones: backoffice PC, backoffice printers, and voice over IP phones. Next we have another domain for the IT administrators, another one for the sales subsystem containing wired and wireless points of sales terminals, and finally the branch user Wi-Fi domain, which provides internet connectivity to the customers. Now, every one of these layer 3 domains has a security policy associated with it. We may see this in the Policies tab. If we look at the branch backoffice policy, we see 2 rules. The first one allows voice over IP traffic from the branch VoIP zone to the voice over IP system in the data center over all TCP and UDP ports. The second rule is used to allow access from backoffice PCs to the inventory service. However, we can see that in the source field we have any, meaning that the access is authorized for the whole backoffice domain, not only from the PCs. Also, full TCP and UDP access is allowed, instead of only HTTP access. We can see this by trying to access the inventory service from the different devices in the back-office domain. First, we try from a back-office PC, and it's successful. Then we try to connect to another machine which is connected to the printer subnet. This machine is not supposed to have access to the inventory service, but we may see that it has. This is clearly a security violation. We will attempt to fix this with a single configuration change for all the branch offices at once. We head back to the VSD, we make sure that the branch back-office domain is selected, and we specify the back-office PC zone in the source field, inventory service as destination, and we will also restrict the communication to only HTTP. This is TCP port 80. I'd like to remind you that this domain contains the back-office zones of all the remote locations in the network. In our example, these are 3 branches, but there might as well be hundreds or even thousands. So once we push the modifications, this change will be propagated instantly to all the remote CPEs. Let's check now if this worked. We'll first try it on the back-office PC. I will start an incognito window to avoid loading pages from cache, and we'll try again. We can see that the connection is still successful. Now, let's check this on the device inside the printer subnet. Again, opening an incognito window to avoid cached pages, we can see that there is no inventory access anymore. Next, let's take a look at the sales subsystem. We can see 2 rules, allowing access from wired and wireless points of sale terminals respectively to the sales sub in the data center via port TCP 443. So all is good here. Moving to the user Wi-Fi zone, we can see a rule allowing full access to the internet for the Wi-Fi users. This is clearly a security violation, since we only want to allow HTTP and HTTPS traffic. We'll fix this as well, but first let's test and see if this is really the case. We log into a machine on the user Wi-Fi subnet and we try to navigate using HTTP/HTTPS. This works. Let's now try opening a public URL on a very specific port. We can see that this works as well. As discussed before, the company's security practices only allow HTTP and HTTPS access for Wi-Fi customers. Therefore, we need to fix this. Again, the domain contains the zones corresponding to Wi-Fi users from all the remote locations in the branch, and it will have a global security policy. We will edit this existing rule and only provide access to using ports TCP 80 and 443, which corresponds to the HTTP and HTTPS protocols. Next, we need to keep in mind another important thing. We will add 2 separate rules allowing TCP and UDP DNS traffic. Before, it was using the same rule giving full TCP and UDP access. Now, since we restricted it to HTTP and HTTPS, we need to make sure that our users will be able to access the DNS servers to resolve internet URLs. Once the policy is pushed, we can test. We head back to our user Wi-Fi machine, we open a private browsing window, and we try again. Loading the custom port public page. We can see that this time the request fails. However, if we try something using HTTP or HTTPS, like google.com, we can see that it works. You have seen in this demo how easy it is by using Nuage Networks SD-WAN to manage security policy at scale. We have fixed several important security vulnerabilities by simply modifying a few global rules and pushing them to all endpoints. This is only possible when having a networking solution with a centralized control plane and a global view of the network. This concludes the presentation. For more information on the retail business solutions provided by Nuage Networks, please check the links in the description of the video and stay tuned for the following presentations.